What you see here is the exact amino acid sequence of Botox. It has a length of 1,296 amino acids and a mass of 149,411 Daltons. AlphaFold, a company based on DeepMind that also won chess and Go competitions against world champions, has now predicted the structure of 200 million proteins. Their predictions are based on the attractive and repulsive forces that different amino acid molecules would have amongst themselves. Here we have the three-dimensional physical structure of Botox. You can see that it has a light chain and a heavy chain joined by a little orangey red spiral section. The color means that the exact shape has not yet been properly predicted. Please excuse the simplicity of this, but this represents a muscle fiber. I'm also trying to make it possible for myself to understand this process. At the muscle fiber, you have a neuromuscular junction, a motor end plate. Inside the end plate, there are vesicles containing neurotransmitters. One of the snare proteins, synaptobrevin, is firmly attached to each of these vesicles. Another of the snare proteins, syntaxin-1, is attached to the inner surface of the cell membrane of the motor end plate. And it is joined by a third important snare protein called SNAP25. I've represented them all with the drawings that you see here. When the synaptobrevin on the vesicle and the other snare proteins on the cell membrane grab each other, they form what is called a core complex. You will remember from your second year physiology classes that when an action potential comes down the nerve fiber, it opens a sodium channel. The sodium enters the end plate, and at that point the voltage in the end plate increases by 40 millivolts. This allows calcium to flow into the end plate. The core complex contracts and smashes the vesicle into the cell membrane. The vesicle wall and the cell membrane or synaptic membrane now fuse, essentially placing the contents of the vesicle outside of the cell. These contents could be a neurotransmitter like acetylcholine, or they could even be a different neurotransmitter like noradrenaline. This is important because we previously used to think that Botox just inhibited acetylcholine. But we are now going to look at what the effect is of Botox and how this release is related to Botox. Here is the Botox molecule we've previously seen, with its heavy chain and its light chain. Now, the heavy chain binds to the synaptic membrane and then binds zinc in the synaptic membrane, allowing a gap for the light chain to pass through the synaptic membrane, and the light chain then attacks the snare proteins and breaks them up or cleaves them. Once the snare proteins have been broken up, there's no way for the vesicles to anchor to them and form core complexes, and as a result, the vesicles containing neurotransmitters will just be floating around aimlessly in the motor end plate, which is now permanently damaged and useless. It will take the formation of a new motor end plate to make the nerve end functional again.